All right, guys. Thank you again for coming for this live lesson. Today we're going to be talking about different properties of water, which covers lesson 2.01 for your biology course. So first of all, these are the properties that we're going to be going over today. So it just kind of summarizes, what we're going to be talking about. And we're going to be talking about that water is a polar molecule. We're going to figure out what that means. We're going to talk about cohesion and adhesion. We're going to talk about high specific heat. We're going to talk about its density, on how it's actually at its greatest density, right about just above freezing. And we're going to talk about why it's the universal solvent of life. So all of these are properties of water. So when we talk about our DBA for Module 2, when I say to mention and talk about two properties of water, these are the properties I'm referring to. So just make sure you have these down. These are the important properties of water that we're going to be discussing today. Polar molecule, cohesion, adhesion, high specific heat, density, and the universal solvent of life. I'll leave this up here for about 30 more seconds, and then we will move on and start talking about the polar molecule. All right. So, speaking of polarity in water, first of all, in a water molecule, you got two hydrogen atoms form a single polar covalent bond with an oxygen atom. That's water. We know water is H2O, right? H2O. Well, here's an H, here's an H, and here's an O. So there's your two molecules of hydrogen bonding with a polar covalent bond. That's the type of bond on how water bonds with itself. This gives water more structure than other liquids. Because oxygen is electronegative, the region around oxygen is negative. Hydrogen is partially positive. So this area of water is positive. This area of water near the O is negative. So that's what you need to know. First of all, water is H2O, and it bonds with polar covalent bonds with two hydrogens linking up with the oxygen. And it looks like Mickey Mouse ears. And the hydrogens are positive, so that's the positive area of water, and the oxygen is negative. So near the oxygen is negative. So now water is going to act like a magnet. And this is where you get the polarity of water. When they say water is polar, all it means is it has a positive end and it has a negative end. A magnet is polar. Our Earth is polar. We have a positive north pole and a negative south pole. Water is also polar. It has a positive end and a negative end. And with that, opposite ends of the molecule have opposite charges. So, if I were to draw, let's go back to here. If I were to draw a water molecule, so we have H, O, I'll label it for you. This area, remember, is positive. This area is negative. Well, positive attracts negative. So guess what? This O on the other molecule, which is negative, is going to attract. And then the other hydrogens will be on the other end. And that's how water molecules stick together, because of opposite charges. So the negative ends stick to the positive end. That's how they stick together. That's how water molecules are polar, and that's what allows them to get these other properties: cohesion, adhesion, specific heat, density, universal solvent. All those properties exist because water is polar. It has a positive end and a negative end. So here's the picture I was just drawing for you guys, see? The negative oxygen goes to the positive hydrogens, and that's how water molecules stick together. There's a variety of unusual properties because of that. And the slightly negative regions are attracted to the slightly positive regions of the molecules. And that type of bond is a hydrogen bond. So far we learned about two types of bonds, right? The water molecule itself is polar covalent bonds. Water sticking to other waters are hydrogen bonds. Don't get confused with that. Hydrogen bonds stick other molecules together, whereas polar covalent bonds organize the water molecule itself. And each water molecule can form with up to 4 different neighbors. So that's why water can bond with itself very easily. Okay? So remember we said hydrogen bonds, this is how other water molecules stick together. This is this picture right here. This water molecule and this water molecule are stuck together by hydrogen bonds. They hold water molecules together. Each water molecule can form up to 4 hydrogen bonds, so they can bond with 4 different waters at the same time. And the hydrogen bonds joining water are weak, about 1/20th as strong as covalent bonds. So that makes sense, right? The bonds holding the water molecule together are 20 times stronger than water linking up with other waters by hydrogen bonds. So covalent bonds are 20 times stronger than hydrogen bonds. They form, break, and reform with great frequency. That's the hydrogen bonds, because they're not as strong, so they can break easily. Extraordinary properties that are a result, remember I said because of these hydrogen bonds, because water is polar, you can have cohesion, you can have resisting changes in temperature, high heat of vaporization, you can have it expand when it freezes, and it's a very good solvent as well. Here is cohesion and adhesion. Organisms depend on cohesion. Co means together. Here's the most perfect example of cohesion versus adhesion. I want you to look at this picture, and for part of your explanation or part of your participation today, I want you to tell me the difference between cohesion and adhesion. That picture will help you out a ton. So go ahead, look at that picture and tell me the difference between cohesion and adhesion. So we got cohesion, so how's that different than adhesion? Cohesion is the same things are bonding together. Right, Joshua. Good job. Good job, Francesca. Yep. Emma, great job. Colin, good. Danielle. Yep. Justice, good. Cohesion and adhesion, good job, Jesus. Yeah, Hunter. Jason Taylor, good. So yeah, cohesion, guys, look, this is where water bonds with itself. Very easy, right? Adhesion, water is still bonding. It's still sticking to other things, but that's the difference. Cohesion is where it sticks to itself. Adhesion is where it sticks to other things. We know water is not sticky, but it does stick to other things because of hydrogen bonds, remember? Because it's partially positive and partially negative, and positives attract negatives, and negatives attract positives. Well, that's why cohesion and adhesion occur, because of hydrogen bonds. Cohesion is responsible for the transport of water, too. And it's among water molecules, and it plays a key role in transport of water against gravity. If you ever put a paper towel and dip it in water, you'll actually see the water climb up the paper towel above the water itself. That's adhesion. That's what they're talking about here. Plants get their water by adhesion, where the water sticks to the tubes of the roots and it climbs all the way up the tree. That's because of adhesion. So cohesion is where water sticks to itself. Adhesion is where it clings to another substance or the wall of different things. So hopefully you know the difference between those two. Pretty simple. Surface tension is another one. This picture right here explains surface tension. So that's what that means. It's a measure of the force necessary to stretch or break the surface of a liquid. It's related to cohesion, right? Because water is sticking to itself, forming a surface. That's why water has a surface tension. And it has a greater surface tension than most other liquids. So if you compare water to gasoline or water to ethanol or water to any other liquid, it's probably going to have a higher surface tension because the hydrogen bonds resist stretching or breaking the surface. So it's because of its hydrogen bonds. Water behaves as if it was covered by an invisible film as well. And some animals can even stand, walk, or run on the water without breaking the surface. Like you see with this certain bug, I don't know the name of it, but you can see that it's not getting wet. It's actually standing on top of the surface. And yeah, that's a good point. There are lizards too that can are adapted where they can run right on top of the water without even getting wet. So pretty cool. But another thing to think about, that's why water, you can't really jump into water from like 100 feet in the air unless you know what you're doing. People have injured themselves by just jumping into water from high heights because of the surface tension. You're much better off jumping into another liquid besides water. Water can actually hurt you by jumping off from a high height because of its high surface tension. So don't ever assume that you can just jump in water anywhere. You have to not be that high up in the air. You can really hurt yourself. So that's all because of surface tension. All right, so we also know that it moderates temperatures on Earth, right? Florida is a great example of that. Water stabilizes air temperatures by absorbing heat from warmer air and releasing heat to cooler air. Water can absorb or release large amounts of heat with only a slight change in its own temperature. So what I'm trying to tell you there is the reason why Florida doesn't get to 120, it feels like 120 sometimes, but the reason why Florida doesn't get to 110 or 120 degrees is because we have water all around us, and it kind of absorbs a lot of that heat, and it releases the heat, versus the desert where you would see 100 degrees, 120 degrees in the summer, and 25 or 30 degrees in the winter, because there is no water holding all that heat and helping it. Florida is surrounded by water, so you can definitely, buffer the temperatures that way. That's why Florida rarely gets below freezing in the winter, and it rarely gets above 90, 95 in the summer. So that's why that happens, because water it moderates temperatures on Earth. And just in case you don't know Celsius temperatures, 0 degrees is freezing for Celsius. We know 32 is Fahrenheit. So 32F is the same thing as 0 degrees Celsius. Room temperature is 23. That sounds cold. But no, that's 72 degrees Fahrenheit. Human body temperature is 37 degrees Celsius. That's 98 degrees Fahrenheit. Water boils at 100 degrees Celsius. Does anybody know the boiling temperature for Fahrenheit? Anyone want to guess? The 32 is freezing, 72 is room temperature, 98 is our body temperature, Water boils. It's between Joshua and Francesca. You're close, Joshua. Hunter, you got it. 212 is the temperature where water boils. Okay? So next we're going to talk about specific heat and heat of vaporization. It kind of deals with this. It kind of deals with water moderating temperatures. Specific heat is the amount of heat that must be absorbed or lost for a gram of a substance to change its temperature. So in other words, specific heat, guys, just means the amount of energy it takes to change the temperature of it. You can change the temperature of some things very easily. Water has a pretty high specific heat, which means it takes a lot of energy to change the temperature of water. That's what that means. 3/4 of Earth is covered by water. It serves as a large heat sink, so it helps out preventing temperature fluctuations. It helps out coastal areas having a good climate, and it also helps a very stable marine environment. Remember, on the coldest day in the year, the water temperature in the ocean is still around 65 degrees. On the hottest day of the year, it doesn't really get much above 90 degrees. So it doesn't fluctuate as much as it does in the air temperature. Air temperature does not have a high specific heat, because you can change it pretty easily. Water has a higher specific heat because it's harder to change the temperature of it. So hopefully that makes sense. Just specific heat means the amount of energy it takes to change the temperature. And water is high, means it has a hard time to change the temperature, versus like air or things like that. Yep. And you won't see the water temperature much higher than 90 or much lower than 60. But we know air temperature can go to 30 in Florida and almost 100 in the summer. So that's what surface-specific heat means. And it also, yes, it depends on how deep the water is. We're only talking surface temperature. Okay, so it also does evaporative cooling. That's when a surface occurs when the liquid evaporates. This helps moderating the climate as well. It stabilizes temperatures. It prevents organisms from overheating. This is evaporation. This is sweating. This is releasing water back into the air. All that humidity, that's evaporative cooling. That's the Earth trying to cool itself off. When we sweat, that's the same thing when Earth evaporates. It's trying to cool itself off. So it does that as well. Yep, and we'll talk about that, Joshua. I think on the next one. Yep, density of water. Here we go. So density of water, this is something that you guys definitely need to know. Water is most dense as a cold liquid. If you put a cold liquid and ice together, you know the ice is going to float to the top. That's less dense. The cold liquid, that 4 degrees Celsius, like the coldest water you can get, that is the most dense, just above freezing. And it contracts until then. But then it expands once it turns to ice. So why do you see ice on the top of lakes but not the bottom? Because ice is less dense than the cold water below it. This also prevents the water from freezing from the bottom up. That's why fish can live in these freezing, frozen lakes in the winter, because below the ice, the water is cold, but it's not frozen. So those fish can stay alive. And the only reason they can stay alive is because water is most dense as a liquid. So don't forget that. A lot of people make that mistake. Water is most dense as a liquid. It is less dense as ice. It forms on the surface first. The freezing of the water releases heat to the water below it, creating insulation. That's why fish can live in these situations. That's why people ice fish. They make a hole in the ice and they can fish below it. And it makes the transition between seasons less abrupt as well, because that water is pretty stable down below. So that's what the density of water means. It's most dense as a cold liquid. It becomes less dense as an ice. Here's a great example. Here's liquid water. Look at all the molecules. There's at least 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 25 molecules of water. So that's pretty dense. When it becomes ice, it actually spreads out. So we don't have 25 molecules in this space anymore. We only have about 15 or 16. So it becomes less dense when it freezes. When water reaches 0, water becomes locked into a crystal lattice state. And each molecule is bonded to a maximum of 4 other molecules. As it melts, the bonds break and some of the water molecules can slip closer to each other. And ice is about 10% less dense. So if you put an ice cube in water right now, you can prove it. 10% of that ice cube will be above water. 90% of that ice cube will be below water. Go ahead and try it if you don't believe me. Get a cup or a bowl, put an ice cube in there, and look at the percent of that ice cube that's above water, 10%. 90% is below water because ice is 10% less dense. Also, if you ever see an iceberg, if you're ever lucky enough to see an iceberg in the ocean, you only see 10% of it. Think of this ice cube rule. So that's another thing about it. You'll see icebergs only 10% because of its density. The other 90% is underneath the water. And then looking at some questions here, with the Dead Sea, you can't sink. That's because of salt. And the salt makes the water very dense, and you're less dense than that. That's why you can't sink. So you are floating because of the density of the water, because of the salt that's in it. Yep, that's similar, but yeah, that's similar. And then the last one is the solvent for life. We know what a solution is from basic science. A solution is where you get a solute, like salt, and you mix it with a solvent, like water. You mix it together, you have a solution. Water is a solvent for life. Because it's partially positive and partially negative, it can dissolve all kinds of things. It can dissolve salt, sugar, minerals, all kinds of stuff. And when water is involved, it's called an aqueous solution. Aqua, so that means water type of solution. And there are 2 different types of solutions, hydrophilic or hydrophobic. Phobic means afraid of water. Phobic, phobia, hydro, so that means no water, non-polar compound. It won't dissolve in water. Hydrophilic, philic means love, so love water. That means hydrophilic things will dissolve in water. Polar molecules dissolve in water. So that's what that means. Water is a solvent for life because it dissolves many things. If it's hydrophilic, that means, like salt, it will dissolve because it's polar. If it's hydrophobic, like oil, it will not dissolve in water because it's non-polar. Okay? All right. Here is your check to get out of here. And here's also your check to make sure that you are participating. Just type out 1, 2, 3, 4. You can do it one at a time or however. But let's actually go one at a time. So number 1, which property of water shows that water sticks to other substances? Which one is that? Or water sticks to other substances? I'm seeing both. Be careful. Which property of water shows that water sticks to other substances? All right, looks like we're getting this one now. Yep, that is adhesion. Remember, adhesion is where it sticks to other substances. Cohesion is where it sticks to itself. So that would be adhesion. Can you name two other properties of water for number 2? Good job, Ciara. Polarity, it's a polar molecule. Density, it is more dense as a liquid. Surface tension is another one. Good. That means it has a high surface, a high ability to break the surface of water. Polarity, density, surface tension. Universal solvent, there's another one. It dissolves many different things. Specific heat, yep. Remember, to change the temperature of water, it's pretty high, so it takes a lot of energy. Same thing with high heat of vaporization. That just means it takes a lot of energy to boil water. So good, we got that. Numbers, yeah, capillary action. Good job. That deals with adhesion as well, where it climbs up small tubes. All right, is ice more or less dense than water? Remember, put ice and water together. Which one goes to the top? That means whatever one's at the top is less dense. Good job. Ice is 10% less dense, which means it has less molecules per space. That's why it floats. It's less dense. Whatever floats is less dense than what's below it. Okay? And then there are two types of chemical bonds that water has. Which type of bond bonds the water itself together? The two H's and the O. What type of bond bonds water itself together? I'm seeing hydrogen and covalent. Be careful, because they're two different bonds. Which bond bonds just H2O together? So H, O. Which bond is this and this? A couple of you guys got it. Joshua, good job. Justice, good job. Ciara, yep. Mila, yep. This is covalent. Covalent, remember polar covalent? Those are the bonds that stick water itself together. Now, that's a covalent bond. But when we talk about water sticking to other water molecules, so we have this, and this, matching with this, and this, what type of bond is that, where water molecules stick together? Good job, Justice, Mila, Francesca, Colin, Helen, Jason, Vincent, Danielle. Yep, very good. Know the difference. Covalent bond sticks water itself together. These bonds here are hydrogen bonds. Those are the bonds that stick water molecules together. And one last question. Which one is stronger, covalent or hydrogen bonds? Which one is stronger of a bond, 20 times stronger? Is it covalent or hydrogen? Which bond is stronger? I say both. I'm seeing mixed results. This bond here, guys, is 20 times stronger than this bond here. Water molecules can break apart pretty easily, but the water molecule itself is a lot harder to break apart. That's why it's a covalent bond, 20 times stronger than the hydrogen bonds that hold other water molecules together. Okay? All right, guys. Well, thank you again for coming. We are all finished for today. Again, I hope you learned about those properties of water: polarity, surface tension, density, capillary action, cohesion, adhesion, and I hope you know about the bonds that hold everything together. So if you got that, you're good. So I hope we'll see you here next week. Thank you guys again for coming, and hope you guys learned something today.